Astronomers are freaking out because reality just pulled a magic trick straight out of a time travel movie. Picture this. You flip a coin, it lands on heads, and then 5 minutes later you decide, nah, tails would have been funnier. Suddenly, the coin insists it always landed on tails, and you're left wondering if you need an exorcist or a better physics textbook. Welcome to the quantum eraser experiment, where reality doesn't just bend, it literally deletes its own past like a teenager scrubbing their embarrassing Facebook posts before a job interview. And no, this isn't Marvel fan fiction or a conspiracy cooked up by that guy at your local coffee shop who won't stop talking about vibrations. This is real, peer-reviewed, lab-verified science. Particles, the tiny Lego bricks of the universe, change their past behavior depending on decisions made in the present. Read that again. Choices you make now seem to echo backwards in time, like yelling "plot twist" at a movie and having the ending rewrite itself. The implications? They're catastrophic for common sense. Time, causality, and everything your high school science teacher promised was stable turn out to be about as stable as a Jenga tower in an earthquake. The universe isn't a nice, predictable clock. It's a cosmic improv show, and the particles are making it up as they go. You thought Schrödinger's cat was confusing? This is Schrödinger's cat texting you from last week to say it was alive, but only because you opened the box tomorrow. And here's the kicker. The effect doesn't tituenan, just happen when you are looking. Even if nobody peeks, just the possibility of knowing changes the outcome. That means reality isn't waiting for your eyeballs, it's waiting for your receipts. Knowledge itself is the currency, and the universe is basically that nosy friend who adjusts her behavior depending on whether you know the tea. It challenges the deepest assumptions we've ever had about time. Like, does the past even exist until we demand a record? Are we co-authoring reality every time we check a result? Or is the universe just trolling us with the ultimate lag switch? Seriously, drop your theories in the comments. I want to know if you think reality is glitching or just petty. And yes, this rabbit hole goes deeper. Way deeper. By the end of this story, you'll question whether the timeline is an arrow, a loop, or just a drunken scribble. You'll wonder if cause and effect are divorced and bitterly fighting over who gets custody of Si Chai. Logic. You'll start eyeing your microwave suspiciously because, for all we know, it's altering the outcome of breakfast retroactively. Before we dive, do the civilized thing. Smash the like button, subscribe, and drop a comment telling me where in the world you hadridor twain. Watching from, because who knows, maybe your location is already being rewritten as we speak. And now, let's watch the universe misbehave. Physicists love to ruin perfectly good afternoons by firing particles at pieces of metal with holes in them. Not because it's useful, but because the universe insists on acting like it's auditioning for a David Lynch film. Enter the double-slit experiment, which sounds boring. 2 holes in a barrier, light shining through. But turns out to be the scientific equivalent of opening a box of chocolates and finding a live raccoon. Here's how it goes. You take photons, the tiny divas of the universe, and shoot them at a wall with 2 slits. If they behaved like tiny bullets, you'd expect them to pile up in 2 neat clusters behind the slits. Clean, logical, satisfying, like socks in a drawer. But no. Instead, they create an interference pattern, stripes of light and dark, the exact kind you get from waves overlapping, like ripples on a pond. Translation: particles aren't just particles, they're also waves. Reality refuses to pick a lane, which makes it less orderly machine and more teenager going through a phase. And if you thought that was weird, Wait until you add a detector. The moment you set up a little photon speed camera to see which slit the particle goes through, the interference pattern disappears. Poof, gone. Instead of waves, the photons behave like bullets, slamming into two boring clumps, as if they suddenly decided to straighten up for parent-teacher conference night. What changed? Did the particles sense they were being watched and get stage fright? Because it sure looks like it. Imagine walking into a gym alone. You flail around, trip over the treadmill, spill your water bottle. Now picture the same moment, but someone's filming. Suddenly, you're an Olympic athlete who never sweats. That's the quantum vibe. The key point here is wave-particle duality. Photons and electrons, atoms, basically the whole zoo of quantum critters, can act as spread-out waves of probability until the instant you measure them. Measurement pins them down into specific outcomes, like a teacher calling roll and catching the kid who always tries to disappear under the desk. Without observation, reality doesn't commit to being in one place. With observation, it's forced to pick sides. The experiment also highlights how deeply allergic the universe is to certainty. You'd think reality would have the decency to just exist in a clear state. Nope. It insists on hanging out in a probabilistic blur, only collapsing into something definite when someone checks. It's like your bank account. You don't know how bad it is until you open the app, and somehow it changes depending on whether you're watching. But here's where it gets more diabolical. Even if you send photons through the slits one at a time, without any buddies to interfere with, they still build up an interference pattern over time. Provided you don't watch. That means each photon isn't just choosing a slit. It's behaving as if it went through both slits at once, interfering with itself. It has the physics equivalent of eating a whole cake and blaming your other self for the missing slices. Wave-particle duality is not just a parlor trick, it's a fundamental feature of the universe. Electrons in your body right now are in smeared-out wave states until they're pinned by interaction. Without that bizarre flexibility, chemistry wouldn't work, atoms wouldn't form, and your morning coffee would just be a meaningless soup of uncommitted particles. Every sip you take is basically quantum mechanics reluctantly holding itself together just long enough for you to caffeinate. This duality isn't something we made up to sound profound. It shows up every time scientists torture reality with carefully designed experiments. The wave-like behavior is undeniable. The particle-like behavior is undeniable. And the switch between them depends on whether information is available. It's less like physics and more like a cosmic loyalty program that changes perks depending on whether you be signed in. The double-slit experiment doesn't just hint that reality is stranger than we think. It shoves your face in it. It says, look, you wanted a neat deterministic world? Too bad. You live in a probability soup, where things only get real when you force them to confess. And once you've seen that confession, the universe shrugs and goes back to being a slippery trickster the moment you look away. Scientists kept running the experiment because, frankly, they couldn't believe it either. Every variation confirmed the same absurdity. Observation changes outcomes. The mere act of seeking knowledge rewires what reality is willing to show. It's like trying to stalk someone online. The moment they see you viewed their profile, they suddenly delete all their embarrassing posts, and now you're left pretending you didn't care anyway. So here we are, staring at particles that refuse to choose between wave and particle until we force them to. And once you get comfortable with that madness, someone decides to raise the stakes, asking, what if we don't just observe, but also track the path a particle takes? Would reality still play coy, or would it crumble into something even stranger? That question cracked open an entirely new layer of chaos, one where knowing becomes more dangerous than lasers, and information itself steps onto the stage as the real puppet master. So the physicists, still not satisfied with breaking reality into a puddle of absurdity, decided to crank things up. They asked a simple, cruel question. Fine. The photons act like indecisive waves until we watch them. But what if we tag them? What if we leave a breadcrumb trail so we know which slit they went through, even if we don't peek right away? That's when the universe basically said, "Cute idea, nerds," and pulled another trick. The moment you attach any kind of marker to tell which path a photon takes, the interference pattern vanishes. Gone. Kaput. Reality switches back into boring bullet mode as though it's on probation. The photon behaves like a tiny law-abiding particle, marching through one slit. No nonsense, no self-interference. It's not about physically shoving the photon or bumping it with a clumsy measuring stick. You don't even need to touch the particle. Just the possibility of retrieving which path information is enough to shut down the wave party. Reality hears you whispering, "I could know," and immediately slams the door like a paranoid roommate hiding something sketchy in their closet. Think of it like labeling beer cups at a college party. If no one knows whose drink is whose, people just float around, sip randomly, and chaos reigns. But slap a name on each cup, and suddenly everyone behaves, because now it matters. That little bit of information transforms the vibe. The same thing happens with photons. Tag them with a slit ID, and the universe reluctantly straightens its tie and says, "Fine, fine. I'll act like a respectable particle." The sheer audacity of this should make you sweat. We're not talking about disturbing the photon with giant equipment. Even if the tagging process is so subtle the photon keeps humming along undisturbed, the interference still disappears. Why? Because knowledge itself, the fact that which path info exists somewhere, changes the outcome. Reality isn't being physically prodded. It's being blackmailed by data. This flips everything you thought you knew about physics upside down. Classical physics says particles have definite positions and trajectories whether you look or not. But here, the very existence of knowable information collapses the wave function. It's like the universe runs on gossip. As long as no one knows, it's free to be wild and wavy. The second there's proof, it goes stiff as a board, pretending it never misbehaved. And get this, you don't even need a human brain to process the info. The particles don't care if anyone actually looks. A detector can record the data and then sit untouched in a lab drawer. The photon already knows that which path information exists in principle, and it reacts accordingly. That's like your diary ruining your reputation just because it exists, even if no one opens it. Physicists found themselves staring at equations that implied the universe doesn't distinguish between "a human saw it" and "it was possible to see it." Observation isn't about eyeballs, it's about information flow. Reality seems to have a built-in policy. If data about the path exists, no interference. If data is erased or unavailable, interference returns. The cosmos is running its own GDPR rules, only stricter. Wave-particle duality is now joined by a deeper, weirder revelation. Information matters more than matter. Knowing where a photon went changes what it does. Not knowing lets it remain a fuzzy superposition. The photon's choice is bound not to physics as we knew it, but to the bookkeeping of knowledge. It's like the universe is less about atoms and more about receipts. This is where your brain should start making screeching noises. Because once you realize that knowledge alone determines whether reality behaves one way or another, you start asking awkward questions. If information has that kind of power at the quantum level, does everything you know ripple out and reshape the universe around you? Is your Google search history altering the fabric of space-time? If so, we're doomed. The whole setup leaves scientists in an existential crisis. Physics was supposed to describe an objective world out there, ticking along indifferent to us. Instead, the double slit with which path tagging suggests the opposite. Reality won't fully commit to a form until the question of what can be known is settled. Knowledge doesn't just describe reality, it polices it, and the chaos didn't stop there. Once researchers saw how brutally witch path information kills interference, they started to wonder whether it could be undone. If information wrecks the wave pattern, what happens if you erase it? Like actually destroy or scramble the data so it can't be retrieved? Could you bring the interference back? As if reality decided, oh, cool, nobody knows, let's party again. That idea was so radical it sounded like prank physics. But the experiments that followed proved the question wasn't just valid. It was the key to discovering how reality might be able to rewrite its own past. The idea started in 1982 when two physicists, Scully and Druhl, decided the universe wasn't weird enough already. They looked at the witch path disaster, the way photons slam the brakes on interference the second you can tell where they've been, and asked the rudest question in science. What if we take the information away? Not ignore it, not politely set it aside. Actually erase it, like dragging a corrupted file to the trash and emptying the bin. On paper, it was madness. In practice, it was even worse, because what they proposed was that if the path data could be scrambled or obliterated, the photons should behave as if it had never existed. Translation: the interference pattern could be restored. Erase the knowledge, and the universe throws its hands up and goes, guess we'll just stay wavy. This means reality isn't a strict parent enforcing rules. It's more like a toddler. If you hide the evidence, it pretends nothing happened. A cookie falls on the floor. You sweep it under the rug, and suddenly, no one's guilty. The photon, apparently, works on the same logic. Delete the breadcrumb trail, and it happily interferes with itself again. Like the tattletale detector never snitched. The shocking part isn't that it works. It's that it only cares about the existence of information, not about whether anyone saw it. If the knowledge can be erased before it's accessed, the photon's past seems to rewrite itself. Imagine your boss firing you, but then destroying the HR paperwork before anyone else reads it. Suddenly, you were never fired. You're still employed, smiling awkwardly at the Christmas party while sipping free punch. The math of this isn't some fringe pseudoscience. It's rooted in quantum mechanics, where probabilities reign until measurement locks them down. Measurement creates a definite reality. But if the conditions of that measurement are dismantled, the system reverts to the soup of possibilities. The eraser isn't undoing physical events. It's erasing the record that would force them to solidify. Reality, apparently, has the memory span of a goldfish with commitment issues. Consider the implications. The act of erasing information doesn't just change the future trajectory of a photon, it appears to alter its past behavior. If the witch path data is wiped, it's as though the photon never chose a path at all. It went back to being a wave, retroactively, like a student tearing up a failed test and insisting they always knew the answers. Reality obliges by grading them on a curve that didn't exist 5 minutes ago. Physicists weren't thrilled about this, not because it broke their experiments, the data matched beautifully, but because it shredded their sanity. The eraser concept basically says the universe doesn't store an objective log of events. Instead, it keeps options open until it knows what knowledge survives. The past isn't locked in stone. It's on a sticky note, and the note can be ripped up. Now you might think, cool, I'll just erase the fact I drunk texted my ex last night, and the universe will patch it up. Sorry, no. This isn't time travel for messy humans. The quantum eraser works on delicate systems of photons and entanglement, not your social disasters. But the principle is the same. If the information is destroyed before it solidifies into an outcome, the record of history reshuffles. You don't get to rewrite your breakup, but you do live in a reality where rewriting is technically possible. just not for you. The psychological whiplash here is immense. We were taught that history is a straight line, marching one event after another. But quantum mechanics hands us a loop-de-loop roller coaster, where cause and effect don't just blur. They actively gossip about each other across time. The photon doesn't politely wait for us to measure it and then freeze. It seems to anticipate whether its future information will survive and then adjust its past accordingly. This is why the phrase quantum eraser is so perfect. It's not about scrubbing chalk off a blackboard. It's about deleting the existence of chalk itself, then pretending there was never a board. It's a cover-up so complete it makes Watergate look like amateur hour. And the universe, instead of punishing the deception, rewards it with beautiful interference fringes, like applause for the best cosmic scam. Once this idea took root, experimentalists couldn't resist. They built elaborate setups with entangled photons, beam splitters, and detectors designed not only to measure, but also to erase witch path data after the fact. The results weren't polite curiosities. They were staggering. The photons obeyed the eraser, behaving as though their entire history had been retrofitted. It leaves us staring at a chilling possibility. Reality is conditional, not absolute. The past can be massaged depending on whether information persists. And if information decides the shape of history, then physics is no longer about objects. It's about bookkeeping. The universe is less a grand machine and more a cosmic accounting system, shredding documents before the audit. But if erasing knowledge can rewrite what happened, the natural next question is even nastier. What if the decision to erase is made after the photon has already hit the detector? What if the choice itself reaches backward and edits reality retroactively, like a director rewriting the script while the movie is already in theaters? John Wheeler, a physicist with the patience of a saint and the imagination of a sci-fi screenwriter, looked at the quantum eraser mess and said, "Hold my chalk." He wasn't content with erasing information after the fact. He wanted to push the absurdity to full-blown existential crisis. His question, what if you wait until after the photon passes through the slits to decide whether to measure or erase? Could your decision in the present reach back into the photon's past and alter what it did before? The thought alone sounds illegal, but Wheeler didn't care. He built what's now called the delayed choice experiment. In this setup, the photon travels through the double slit as usual, but the decision about how it's measured, whether to preserve which path information or erase it, is made later, often milliseconds after the photon has already committed to a path. The outcome still depends on that last-minute choice. Imagine tossing a coin, letting it land, and only then deciding whether you wanted it to be recorded as heads or tails. Magically, the coin obeys. It's as though reality keeps the outcome on standby, waiting for your opinion. The photon behaves the same way. Until the knowledge is locked in, its past remains negotiable. Wheeler basically proved that the universe isn't just probabilistic, it's procrastinating. This isn't speculation. The experiment has been run in labs with lasers, beam splitters, and detectors that switch configurations at the last possible moment. The results are consistent. The pattern at the detector changes depending on that delayed decision. The photon behaves as if it knew what choice would be made later, adjusting its earlier behavior accordingly. That's like your dog wagging its tail today because it knows you'll buy treats tomorrow. Either the particles are clairvoyant, or our definition of time is broken. Let's be clear, the photon isn't physically traveling back through the apparatus to redo its journey. Nothing in the lab rewinds. What changes is the interpretation of its past. If the witch path information is preserved, the photon's history solidifies as, I went through slit A or B. If the information is erased, its history is rewritten as, I was a wave interfering with myself. The past is flexible, bending around whatever the future requires. This bends causality into a pretzel. In classical physics, cause comes before effect. like bad pizza before food poisoning. But in Wheeler's world, the effect can reach backward, reshaping the cause. It's as if the food poisoning decided whether the pizza had anchovies hours after you ate it. You can't build a sensible worldview on that without feeling like you're living inside a cosmic prank show. The psychological horror here isn't just that reality is unstable. It's that our choices appear to sculpt the past. The universe isn't waiting for us to peak. It's waiting to see how we'll frame the knowledge. And only then does it declare what really happened. Reality is a passive-aggressive roommate, refusing to define itself until you make a decision, then insisting that's what it was doing all along. Scientists tried to wiggle out of this by suggesting hidden variables. Maybe the photon had a secret plan we just didn't know about. But every attempt to pin down such variables collapsed under the weight of experimental data. The photon doesn't have a hidden script. It literally refuses to choose until the conditions of knowledge are set, no matter how late in the game. Wheeler himself described it with poetic menace. No phenomenon is a phenomenon until it is an observed phenomenon. Translation: if no one locks in the information, the past remains a mushy draft, not a finished story. This isn't just a physics result. It's an existential gut punch. You've been taught your entire life that the past is settled. Turns out, it's editable footnotes scribbled in pencil, waiting for your eraser. Even more disturbing, the delayed choice setup doesn't require human consciousness to make the call. Machines can flip the switch randomly, and the effect still works. The photon doesn't care if a person is watching. It only cares whether the conditions of information dictate a fixed outcome. Observation isn't human-centric. It's universal bookkeeping. The photon's past is less about memory and more about paperwork. If your brain is screaming right now, good. It should be, because this raises an unholy question. If the present can rewrite the past at the quantum level, what happens when we scale this up? Could the same principle apply to larger systems? Could choices today ripple backward into yesterday's probabilities, rewriting events before they harden into history?
The obvious next step, because scientists never know when to quit, was to ask, okay, photons can have their past rewritten, but what about bigger stuff? Can we bully reality at larger scales, or does the universe slap our hands away? This is where things escalate from fun science trick to cosmic identity crisis. Take electrons. Unlike photons, they have mass, charge, and a serious attitude problem. Yet, when fired through the double-slit setup, they also produce interference patterns. That means even matter, literal chunks of stuff you're made of, can exist in smeared-out wave states until someone peaks. Congratulations, your very atoms are indecisive teenagers too. And if you try tagging witch path info for electrons, the same rule applies. Interference dies the second the possibility of knowledge appears. Reality doesn't care that electrons are heavier and sassier. The cosmic gossip law still applies. But why stop there? Physicists, being the masochists they are, decided to scale up even further. They fired entire molecules, buckyballs, those soccer ball-shaped clusters of 60 carbon atoms, through double-slit experiments. And guess what? They interfered with themselves like photons at a rave. 60 atoms, a respectable piece of matter, behaving like a fuzzy probability smear until someone dares to ask where they've been. Imagine your grandma's fine china deciding to be both broken and unbroken until you open the cupboard. The logical consequence is horrifying. The wave-particle circus doesn't stop at molecules. In theory, it extends to anything. People, planets, pineapples. The only reason you don't see your neighbor's car interfering with itself in the driveway is that decoherence kicks in. That's the technical term for when objects interact with their environment so relentlessly that their wave functions collapse almost instantly. In other words, the universe enforces realism at scale by drowning big objects in information noise. But at the fundamental level, nothing escapes the gossip rule. Decoherence doesn't solve the problem, it hides it. It says, look, technically your car could be in two places at once, but in practice, air molecules, photons, and even cosmic microwave background radiation are tattling on it constantly, so the superposition collapses before you notice. That's like saying you could live a double life, but your nosy neighbors keep blowing your cover. The universe is basically one giant small-town rumor mill. And yet, even with decoherence trying to keep things tidy, clever experiments still push the boundaries. Researchers have entangled larger and larger systems, from atoms to superconducting circuits to groups of thousands of particles. The eerie influence of measurement, knowledge rewriting the past, doesn't go away. It scales. It whispers that if we ever figure out how to insulate bigger systems from decoherence, we could watch entire macroscopic objects play the same delayed choice games as photons. Picture Schrödinger's cat again. It's not just a thought experiment with a box, poison, and one very unlucky feline. At its core, it's the same principle. Until information about the cat's fate is accessed, the cat is both alive and dead. If we built a quantum eraser for that setup, erasing the path data before observation, the cat's history could, in principle, retroactively reassemble into a superposition. You could erase the knowledge of whether the poison was triggered, and suddenly the past bends to match the missing record. Try explaining that at the vet. This scaling up attempt forces us into ugly philosophical territory. If information determines reality, then consciousness, which traffics in information, suddenly looks like it might have a starring role. Not because the universe cares about human thought, but because every act of observation is another node in the information network that pins down what is real. You aren't just living in the universe. You're part of the machinery forcing it to pick a story. And here's the kicker. Delayed choice experiments don't care when the choice is made. A decision in the present rewrites the interpretation of events in the past. If larger systems could be dragged into this quantum circus, then in some mind-melting sense, your current decisions could ripple backward into the probability soup that birthed you. Don't panic. Your pizza order last night didn't rewrite the Big Bang. But in principle, the line between cause and effect is blurrier than anyone is comfortable admitting. This is why physicists start looking more like philosophers after a few decades of this work. They can crunch the equations just fine, but explaining what those equations mean in human language feels like trying to fold a fitted sheet. Every time you think you've got it, the corners snap out and slap you in the face. Does the universe wait for observation before choosing? Does the past even exist before information is locked in? Or are we just projecting our desperate need for order onto something that thrives in chaos? The worst part is, experiments don't rescue us with clarity. They just keep confirming the madness. Every time we push the boundary, bigger molecules, faster detectors, sneakier erasers, reality bends but doesn't break. It continues to play by rules that make no classical sense, yet deliver flawless predictions. Nature is like a comedian who never breaks character, no matter how much you beg for a straight answer. And once you're forced to admit that your cozy sense of cause and effect is an illusion, you start asking nastier questions. If knowledge can retroactively sculpt the past, what does that say about free will? Are your choices actual decisions, or just the universe folding timelines around the information you happen to access? If your choices can ripple backward into probabilities, the courtroom of philosophy has a new scandal to prosecute: free will. The classic debate is whether you steer your own life or whether neurons, genes, and childhood traumas are pulling the strings like a Netflix docuseries on autopilot. Quantum mechanics doesn't settle the debate. It sets the courtroom on fire, then sues you for arson. Consider this. In the delayed choice setup, the photon doesn't decide. It's passed until you choose how to measure it. That makes your choice look like the big boss, the final editor of history. Free will wins, right? Cue triumphant music? Not so fast, because your choice itself may not be as free as you think. Neuroscientists have been poking brains in labs for decades, and they've found something deeply inconvenient. The brain often makes decisions before you consciously register them. In the 1980s, Benjamin Libet strapped electrodes to people's heads and asked them to flex a finger whenever they felt like it. He found brain activity ramping up several hundred milliseconds before subjects reported deciding. Translation: your neurons had already placed the Amazon order before you knew you wanted a new blender. Conscious choice might be more like the email confirmation after the transaction, not the transaction itself. Layer that depressing neuroscience over quantum mechanics, and things get wild. If your decisions aren't truly yours, then what exactly is deciding whether a photon behaves like a wave or a particle? Maybe your brain's unconscious computations are the puppeteer, and your free will is just a clueless spectator cheering for moves already made. Or worse, maybe the universe itself nudges the outcome by feeding your neurons the illusion of choice. Reality could be spoon-feeding you lines like a bad actor reading cue cards. But it doesn't stop there. Experiments with random number generators, coin flips, and quantum randomizers have shown that delayed choice results don't care if the decision comes from a human, a machine, or pure chance. The photon reacts the same. That suggests your free will isn't special currency in the universe. Information is the real currency, and your choices are just one more way it gets minted. The universe doesn't care whether you're a conscious being or a glorified coin toss. As long as the bookkeeping is done, reality locks in. This is where determinists puff up their chests. They argue that if the past is rewritten based on future conditions, then everything is still chained by the laws of physics. Your feeling of freedom is just a glitch in the program. They point to the equations and say, "See? No loopholes. You're a machine." But then indeterminists, the quantum hippies, fire back. "No way, man. The universe leaves room for probabilities, so our choices matter in shaping outcomes." It's the nerdiest shouting match you've ever heard, with both sides equally miserable. Meanwhile, psychologists look at the fallout and laugh, because they've known for years how fragile the concept of choice really is. Studies show your decisions can be manipulated by everything from what song is playing in the background to whether you smelled fresh bread on the way in. People primed with words like elderly literally walked slower down hallways. That's not free will. That's a glitchy algorithm responding to environmental nudges like a Roomba stuck under the couch. So picture this. At the quantum level, your decisions might rewrite the past. At the psychological level, your decisions are hacked by bread smells and hallway lighting. Combine those, and you're basically a time-traveling puppet of marketing campaigns and sensory cues. The cosmos isn't a grand stage for human freedom. It's an improv show where you don't realize the script was slipped under your chair 3 seconds ago. And yet, the human ego refuses to die quietly. People cling to the idea that their choices matter, because without it, morality collapses. If every action is just physics crunching numbers, then why punish crime or reward kindness? Free will, even if it's a placebo, is necessary for civilization to function. Try telling a jury, "My neurons made me rob that bank, Your Honor," and see how well that goes. Society needs the illusion, even if physics laughs behind the curtain. The real headache comes when you fuse quantum eraser logic with human decision-making. If erasing which path data can rewrite the past of a photon, what happens when you erase the record of a choice? Delete an email, shred a document, wipe a hard drive. Are you just cleaning up mistakes, or are you bending the causal chain that defines your history? Information isn't just power. It's the glue keeping reality consistent. Lose it, and even your past starts wobbling like bad Wi-Fi. At this point, the universe feels less like a machine and more like a courtroom drama where evidence can be planted, erased, or fabricated, and the jury just shrugs and rewrites the verdict to fit the record. Reality doesn't care about truth. It cares about receipts. And if those receipts vanish, history is free to remix itself into whatever version aligns with the surviving data. Which drags us into an even nastier swamp. If knowledge shapes reality, who or what is the ultimate observer keeping track of everything that happens when no human is looking? If reality only locks in once the receipts are filed, the uncomfortable follow-up question is obvious. Who's keeping the books when no one's watching? You don't personally observe every raindrop, every ant leg, or every photon ricocheting off Jupiter. Yet the universe doesn't seem to glitch out whenever you look away. So something or someone must be running the ledger. Enter the concept of the ultimate observer. Some physicists and philosophers argue that the environment itself plays the role. Every particle interacts with others, and those interactions spread information like cosmic gossip. A photon bouncing off a tree leaf doesn't need you to see it. The environment has already recorded the event in scattered particles of light, heat, and vibration. It's like the paparazzi of physics. Once the flashbulbs go off, the evidence is everywhere. You don't need the New York Times to publish it. The raw data is already impossible to erase. That's the tidy, no-nonsense explanation. But of course, humans can't resist messier ones. Some have suggested that consciousness itself is the ultimate auditor, the stamp of approval that finalizes reality. This is where quantum mechanics veers into a philosophy seminar wearing a turtleneck. If human awareness is required to collapse wave functions, then the cosmos is essentially a stage waiting for the audience to clap. Without conscious observers, maybe the whole show is just fuzzy probabilities hanging backstage. It sounds flattering, you, the mighty human, giving reality permission to exist. But dig deeper, and it falls apart fast. For one thing, the universe got along just fine for billions of years before anyone had a prefrontal cortex. Galaxies didn't wait for Homo sapiens to crawl out of caves before deciding whether stars should ignite. The idea that the cosmos twiddled its thumbs for 13 billion years, waiting for humans to show up, is so egotistical it makes geocentrism look humble. Still, the idea has fans. Consciousness as observer is like horoscopes. It's scientifically flimsy, but people love it because it makes them feel special. Unfortunately, experiments show that collapse happens without us. Detectors, computers, even random environmental noise are enough to settle outcomes. The universe doesn't need you to wave hello before crystallizing its probabilities. You're not the VIP guest at reality's nightclub. You're the guy in line outside while the bouncer already let the important particles in. That doesn't make the problem disappear, though. If the environment is constantly measuring itself, then reality is less about things and more about records of interactions. Every event is logged in a decentralized cosmic blockchain. No central server, no master archive, just an endless network of particles ratting each other out. It's gossip physics all the way down. But even gossip has loopholes. What happens when information is destroyed, as in the quantum eraser? If the environment is the accountant, then erasing data is like burning receipts. Suddenly the past has wiggle room. This is where things get terrifying, because it implies that the integrity of reality depends on whether records are preserved or shredded. The universe isn't a granite monument. It's a filing cabinet vulnerable to paper shredders. Physicists realized this problem wasn't confined to photons and slits. Black holes raise the stakes. When Stephen Hawking proposed that black holes slowly evaporate, he also implied they could destroy information about everything that fell in. That's the infamous black hole information paradox. If true, it means the universe has giant cosmic shredders erasing records wholesale. And if information really is the backbone of reality, then black holes aren't just dangerous. They're vandals ripping pages out of the cosmic ledger. Cue decades of screaming arguments. Some insisted information is preserved somehow, encoded in subtle radiation at the event horizon. Others thought maybe the laws of physics need rewriting. The paradox became the scientific equivalent of a family feud. Everyone yelling, nobody budging, Thanksgiving dinner's ruined. But the common thread was clear. Whether in black holes or photon experiments, information wasn't just decoration. It was the foundation holding reality together. That makes you wonder, if the cosmos is a ledger and information the ink, what happens when the ink runs dry? What if erasure isn't just a lab trick, but a universal mechanic, a way reality edits its own draft? And if that's the case, then who or what has the authority to do the editing? If we're not the ultimate auditors, maybe we're just junior clerks filing paperwork in a system far bigger than we understand. Which drags us into an even more dangerous possibility. Maybe there is a central authority, some overarching mechanism that ensures consistency across the whole system. Not a conscious God with a beard, but a principle, a law of physics we haven't identified, that serves as the cosmic IRS, double-checking every transaction to prevent contradictions. But if such an enforcer exists, why does it allow loopholes like quantum erasers and delayed choice experiments? Why does it tolerate evidence being destroyed and the past being rewritten? If there's a cosmic IRS, it's the worst accountant in the galaxy. Because while it's supposedly making sure reality balances its books, it still leaves glaring loopholes wide enough to drive a quantum truck through. The double slit with erasers, the delayed choice setups, the black hole information fiasco. All of them are basically reality's tax fraud schemes. And like any decent loophole, they're both infuriating and strangely irresistible. One theory says the loopholes are illusions, artifacts of how we describe things, not how things really are. That's the shut up and calculate crowd's motto. They're the ones who say, stop asking what it means and just run the equations. It's like your Wi-Fi provider telling you not to worry about the mysterious $9.99 surcharge. The system works, so quit complaining. This camp insists that photons don't decide anything, pasts aren't rewritten, and reality isn't procrastinating. It's just math, and math doesn't owe you an explanation. But humans are allergic to silence. When told to stop asking questions, we do the opposite, loudly, and usually while inventing even dumber ones. So the loophole problem invites every flavor of interpretation. Some physicists claim the universe splits into parallel worlds whenever measurement happens. That's the many worlds interpretation. Instead of the photon choosing a path, both paths happen, just in different universes. You don't erase information, you just exile it to another timeline. It's the multiverse version of sweeping dirt under a rug and then selling the rug on Etsy as vintage. Others cling to pilot wave theory, where hidden waves guide particles like a cosmic Uber driver. In this view, reality isn't indeterminate. It just has an under-the-table navigation system we can't see. But the problem is that this explanation drags in spooky, non-local connections that make relativity nervous. You end up with a universe that's less elegant clockwork and more back-alley deal between mob bosses. Then there's relational quantum mechanics, which says reality isn't absolute at all. It depends on who's doing the measuring. Like Instagram stories, what's real for one observer may not be real for another. That means the universe is basically a social network of perspectives, and the truth is whatever your algorithm feeds you. Which, to be fair, feels depressingly accurate in the age of misinformation. But none of these interpretations close the loopholes. They just wallpaper over them with different patterns. The fact remains, experiments show outcomes changing based on knowledge, information, and erasure, no matter how you interpret it. Reality allows wiggle room where you'd expect rigid rules. It's like playing Monopoly with a 6-year-old who keeps inventing new house rules mid-game, and you can't call them out because technically, they still win by their own nonsense logic. The loophole issue also infects time itself. If delayed choice experiments suggest the present can influence the past, then causality, the bedrock of every narrative humans cling to, becomes negotiable. And if causality can bend, then maybe free will and determinism aren't opposites at all, but two sides of a Mobius strip. You think you're choosing, but your choice might be dictated by a future condition, which itself depends on your choice. Its feedback loops all the way down, like a microphone squealing in the hands of an amateur wedding DJ. This is why philosophers love quantum mechanics. It gives them infinite ammo to annoy everyone else. Suddenly, questions like, does the moon exist if no one looks at it? Aren't just stoner dorm talk. They're legitimate topics in scientific journals. Einstein hated this. He famously quipped, "I like to think the moon is there even if I'm not looking at it." And the quantum community basically responded, "Cool story, Al, but the math says we can't guarantee it." Imagine being Einstein and getting dunked on by probabilities. The loophole also puts pressure on the very idea of objective reality. If what's real depends on what information exists, then reality is relational, conditional, provisional. Pick your favorite depressing adjective. That doesn't mean you'll walk into your kitchen and find your fridge missing because you didn't think about it. But at the microscopic level, existence itself is playing peekaboo, and you're stuck trying to write rules for a game where the referee keeps vanishing. And here's the sinister part. Loopholes invite exploitation. If reality lets its past wobble depending on information, then in theory, an advanced enough civilization could hack it. Not with ray guns, but with information control. If you can erase, preserve, or manipulate data at the right scale, you could sculpt outcomes by rewriting probability histories. Forget spaceships. The real superweapon would be a quantum shredder, which sparks the disturbing suspicion. What if loopholes aren't bugs at all, but features? Maybe the universe needs flexibility to allow complexity, growth, or even life. A perfectly rigid, causality-locked universe might be sterile and boring. Loopholes inject uncertainty, and uncertainty breeds novelty. The same instability that makes photons behave like liars could be the engine that makes reality interesting enough to evolve minds capable of asking these questions in the first place. That idea sounds poetic until you realize it means instability isn't a glitch, it's the rulebook. And if instability is the rulebook, then the very ground under your feet is less solid than you've been led to believe. Which begs the most unsettling question yet. If the universe runs on loopholes, what happens when one swallows something too big to ignore? Imagine a loophole not at the scale of photons or molecules, but something planetary. A crack in reality's bookkeeping, so wide it doesn't just tweak an interference pattern, but bulldozes causality across whole regions of space-time. This isn't pure fantasy. Physics has already identified a few suspects. Take vacuum decay, for example. According to current models, our universe might be metastable, like a rental apartment held together with duct tape. There's a true vacuum lurking below our current energy state, and if some quantum fluctuation ever triggered it, the laws of physics as we know them would collapse. Not metaphorically, literally rewritten. Light, matter, chemistry, life, your favorite pizza place, gone in a bubble of new physics expanding at the speed of light. It wouldn't even hurt, because you'd be erased before your brain had time to panic. If loopholes are safety valves, this one's basically the cosmic self-destruct button taped to the wall. And then there's wormholes. The equations of general relativity don't forbid shortcuts through space-time. They just demand negative energy to keep them open. Negative energy isn't exactly lying around in barrels, but quantum mechanics says it does pop up briefly in fluctuations. Stitch enough fluctuations together, and suddenly you have a loophole big enough to drive a spaceship through. Congratulations. You've just turned the universe into an interdimensional Swiss cheese. But the nastiest loopholes involve time. Closed time-like curves, solutions to Einstein's equations, allow for paths that loop back into the past. In other words, time travel isn't outright banned. It's just tucked into the fine print like an embarrassing clause in your internet contract. Physicists call it chronology protection, when they try to argue nature won't allow it. That's not science. That's a legal team praying nobody notices the clause that lets you sue for infinity dollars. If time loops exist, then quantum mechanics erase the information, rewrite the past, trick suddenly scales up to horror movie levels. You wouldn't just be dealing with photons politely adjusting their interference. You'd have entire events wobbling in and out of consistency, depending on who holds the receipts. Historians would become the most dangerous people on Earth, because editing archives could literally edit history. Imagine Wikipedia wars where reality itself changes depending on which moderator hits save. Now, some scientists argue that paradoxes, killing your grandfather, buying Bitcoin too early, would prevent these time loopholes from being stable. But that's an assumption, not a guarantee. The universe hasn't promised to keep your narrative tidy. For all we know, it's already patching paradoxes on the fly, sewing over contradictions with quantum duct tape while you blithely go about your day. If you've ever lost your keys in a place you know you didn't put them, maybe you've already brushed against the seam. And black holes are still the elephant in the room. Hawking radiation suggests they leak information, but nobody agrees on how. Some say it's encoded in subtle correlations in the outgoing particles, like cosmic steganography. Others think the event horizon acts like a holographic surface storing data. A few argue reality doesn't care and the information is gone, deal with it. If the last group is right, then black holes are giant loopholes actively shredding reality's paperwork while the cosmic IRS looks the other way. That last option terrifies physicists because it suggests unitarity. The principle that information is preserved in quantum mechanics isn't sacred. If unitarity breaks, then physics isn't just incomplete, it's lying to us. Equations that predict perfect conservation would be masking a universe that occasionally loses receipts like a shady casino. And if reality can lose receipts in black holes, why not elsewhere? The logical extension is unnerving. Maybe loopholes aren't rare. Maybe they're the rule, and consistency is the rare fluke. What you call laws of physics could just be the local bylaws of one stable pocket in a much bigger, much sloppier system. Outside our neat bubble, maybe the rules bend, fracture, or reset entirely, and our universe only looks orderly because it's one of the few branches where the cosmic accounting hasn't imploded yet. That suspicion has teeth when you consider quantum field theory already allows infinite energy fluctuations at small scales. It just politely cancels them out with renormalization. A mathematical trick that's basically physics sweeping infinity under the rug and saying, "Don't look there." If you ran a business that way, you'd be in jail. But the universe gets away with it because there's no auditor above it, or maybe there is, and we just haven't noticed the fines yet. Which leaves us staring at a very uncomfortable possibility. What if loopholes aren't just tolerable? What if they're exploitable? If advanced civilizations exist, maybe they've already learned to game reality's accounting system. Not by inventing faster rockets, but by nudging probabilities, erasing information, or bending time loops until causality flinches. A species that masters loopholes wouldn't just conquer space, it would conquer reality itself. And if they're out there, it raises a chilling question about why we haven't noticed them.